In a try now section for the exponent law. So let's see what we remember. Let's see if we can get all these rules. So when it is division, we are doing subtraction. You don't have to write what's in the bubble there. You're keeping the base. So the base here is a 5. So decide what the base is. And we're going 6 minus 2, so 4. The instructions for this one are simplify. So that means I don't have to evaluate it. I can just leave it like that, 5 to the 4. This next one here, this is a power to a power rule. So when they're 2 power to a power, we're multiplying. The base itself is m, and we're multiplying, so 2 times 4 is 8. This next one, the base of this one, so grab the base first, is -6. So grab the base, -6. And when we are multiplying them, so it's -6 to the 7 times -6 to the 4, we are adding. So 7 plus 4 is 11. And make sure you grab the base, the whole base here, because there's brackets here. Like that, you're grabbing the whole base here. Right, for the next one, we have the base of g. So 3 and the 4, we're adding them. So 3 plus the 4 gets me, and I'll just write this with a 7. And then the base of h, so grab the h, that's 2 plus invisible 1. 2 plus 1, so that gets me a 3. And that's it. Here, I have more than one thing happening, so there's a numerator and a denominator. I always say cover up the numerator and denominator, do them like separate questions. So the numerator, there's nothing to do. There's an a to the 12 and b to the 9. But the denominator, I have a power to a power rule. So that means both of these, so it's just like what we did here, both of them get a power of 3. So that means for the numerator, leave it as is. But for the denominator, I have a to the power of 3 to the 3. 3 times 3 will get me a 9. And I also have the base of b, the base of b. 2 times 3 gets me 6. So each one is multiplied. So multiply, multiply. 3 3s gets me 9. 3 2s gets me a 6. Then you're going to do the division. So the division, you can do the division with each base. So that one divides with that one, and this one divides with this one. So we're going to go like this. We're going to say that the A, notice I'm putting equal signs. So sometimes when we're doing all of this work, people forget to write equal signs because you're so busy on the rules, but you do have to make sure you have the proper equal signs. This is division, so we're going to subtract. A, keep the base of A, subtract downwards, 12 minus 9, so 3. The base of B, 9 minus 6, so 3 left. And you stop here, you're done, that's all you can do. Okay, let's keep going. Looking at this, I have a to the 4 times a squared to the power 5 divided by x to the, x, am I saying a? X to the 4, x squared to the power 5 divided by x to the 6. So here, you want to look to see which of BEDMAS we're working with. And when we look at this, we know this will be a power to power, so we're going to multiply. That's the E part of the exponents of this part of the BEDMAS. You can do the division multiplication after. So the first thing I want to do, though, is write this as is, like this. And we're keeping the base of x, and 2 times 5 is a 10. So 2 times 5 is a 10. Then here, we have all multiplication and division, so we're going to go left to right, because we have multiplication and division, so left to right in that case. So as we go left to right, we're going to do these two, so we're going to add them. You don't have to do what's in the circle, but I'm telling you it's x to the 14. And that's divided by x to the 6. And these two here, we're going to subtract. You don't have to, I'm just showing you what I'm doing in the circle. You don't have to write that part, but it's going to be x to the 14 minus 6, so x to the 8. And you stop there. Okay, we're almost there. We're going to look at this one now. So this one has an instruction, simplify, then evaluate. So it's got two parts to it. So simplify first. We're going to do that first. So first do this. And then second, you're going to evaluate. So first simplify it, then evaluate. So this question here, I gave you a big one here. So we're going to look at this. There's a bunch of stuff happening in the numerator and denominator. When you start to get overwhelmed like this, I always say with these questions, I want you to treat it like a bracket. Finish all the numerator first. So we're going to just do the numerator first. I'm going to put the equals here and then line that up. So this here, I've got power to a power rule first. I'm going to do this part here, which is multiplication. So I'm going to grab the base. What's the base? The base is the -4 with the bracket. So grab that whole base with the bracket. And 2 times 6 gets me 12. And I'm writing the rest of it exactly as it is. I didn't do this part yet. Look at the denominator. It's like a separate question. And we're doing this part here. When you multiply, you're adding the exponents. So this base is -4. 2 plus 4 is 6. Okay, keep going. The numerator still has something else to be doing, to be done here. So we've got division, which becomes subtraction. So this here is going to be subtraction. So grab the base again. 12 minus 3, that gets me a 9. This I have not touched yet, so this is still the same. But now we have division again, which is going to be subtraction. So grab the base, which is still -4, the whole base. Subtract it. 9 minus 6. 9 minus 6 gets me 3. So get up to there. That's my simplifying. And then my second part, so that's part 1. My second part is I'm going to actually evaluate it. -3 negatives gets me negative, negative, negative. 3 negatives will get me a negative. -4 times -4 is positive 16 times another -4 gets me -64. That's why it's 3 negatives gets me a -64. So then you calculated it. So evaluated it. So simplify first part, evaluate last part. Okay. So that was a long question. So now let's just try some evaluate questions. So this last bit here, all I want to do is evaluate these guys. So here I've got -3 to the 4, but notice I'm putting brackets on some and no brackets on the others. So no brackets means in your brain that this negative, there's only one. So there is only one negative. So this part here, there's only one negative. But this part here, 3 to the 4, there's 4 3s. So if you do in your head or on your calculator, 3 times 3 is 9, times 3 is 27, times 3 is 81. So you can do that on your calculator. So you can go 3, this arrow up means to the exponent, so to the exponent 4, like that. So it's 81, but you're keeping the negative in front. There's only one negative and 4 3s, so it's 81. And remember, the instruction for this one is evaluate. This one, there are 4 -2s. So if there's 4 negatives, so if this is even, if there's 4 negatives, negative, negative, you've got 1, 2, 3, 4. Every 2 negatives cancel to be a positive. So an even number of negatives gets me a positive answer. So an even number of negatives, so even number will get me a positive. 2 times 2 is 4, times 2 is 8, times 2 is 16, so we're writing 16. So it's 4 negatives, which makes it positive, and 2 to the 4 is 16. Okay, we're almost there. Let's try -5 to the 3. That means, again, there's 3 negatives. Every 2 negative gets you a positive, so that would be 1 extra negative, so it's got an extra negative. 5 times 5 times 5 is 125, and that's it. So we're getting used to brackets or no brackets. Okay, let's try that again. Here, there's only one negative. One negative, so it sits in front. And then we're going to go 2 times 2 times 2, which gets me 8. Okay, let's see if you understand the even odd. So if it's an odd number of negatives, then it's a negative because you have 1 left over. If it's an even number of negatives, then it's positive because they cancel out. So an even number of negatives versus a positive. So our last bit here, let's look. If I have an odd number of negatives, I know my answer is negative. If I have an even number of negatives, I know my answer is positive, so I don't have to write it. So odd number is negative, even number is positive. 1 times 1 times 1 times 1 times any is 1. Here, 1 times 1 times 1, 26 times is still 1. So this would be positive because it's even, and this would be negative because it's odd. That's a nice little trick that we've been starting to develop here, so hopefully you understand that one now.